Welcome to this instructional video on drawing organic molecules. So let's say you're given the formula C5H10O2, and I need you to draw a structure, a legitimate structure that follows the rules of bonding. By the way, do you have in front of you right now the guide to drawing molecules that I gave you? If not, stop and go get it. Okay? I need this structure to have a carbonyl, and I will say one carbonyl, I would tell you that, one carbonyl and 0 hydrogen bond donors. So how are we going to make this happen? Well, I've given you some information to start with. I'm telling you this has a carbonyl group, and that's a very common fragment in many of the families that you are asked to draw. So there's the carbonyl. And again, I'm going to draw this carbon a little bit better just because I want this to look good. And I hate that, so let's try it again. There we go. So you've got to have 5 carbons, 10 hydrogens, 2 oxygens, 1 carbonyl, and no 0 hydrogen bond donors. So I think I'm going to use this carbonyl as a landmark. I'm going to go ahead and I'm going to draw it in, and then I need to add other atoms to fill in the structure to meet the formula and to meet the other demand of having 0 hydrogen bond donors. So here's one way this can happen, and this is one where there's several different structures, okay, that meet this criteria. What about this? What if I put in an OH? So I've taken care of 1 carbon, both oxygens, and 1 hydrogen. And so all I can do now is just add in carbons over on this side, because you can't bond further to the right. Never bond off a carbonyl oxygen. Ladies and gentlemen, write this down. Get the brightest red marker you can find and circle it. Never bond to the oxygen of a carbonyl. That never works. That's not going to work for us. Okay? And you can't bond off this way. So the only way to add bonds, and certainly you wouldn't want to put another bond off here, that'd be 5 bonds, a catastrophe. A catastrophe. So I'm going to put the remaining 4 carbons off of here. And then I'm going to fill in hydrogens and see if this meets one or more of the criteria that I have set forth. So it looks like we have 5 carbons, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, 2 oxygens. So we meet the formula. It has a carbonyl, but oh no, look at this. This is a donor, a hydrogen bond donor. Ladies and gentlemen, this is not going to work. If I didn't have the stipulation to have 0 hydrogen bond donors, this would work. But this will not work because of that. By the way, this is a carboxylic acid. It's a lovely structure. It just doesn't work for this particular one. So what are we going to do next? Well, I'm going to come down here and I'm going to try again. I'm going to keep my carbonyl in place because I know it's got to have a carbonyl. This time I'm going to put an oxygen here. Look at this. You should see this fragment. It's 2 of these fragments married together here. Carbonyl and then an oxygen with 2 bonds and 2 lone pairs, right? And so I've taken care of, let me draw the formula, write the formula for us, just to remind us. I've taken care of 2 oxygens, and now I need to add, and I've taken care of 2 oxygens, 1 carbon. I got to add 4 carbons. So I have to add on this right here or this right here. That's my only choices to add to. So I'm going to add a carbon here. 1, 2, let's just do 1 here, 3, 4. And then I'm going to fill in the hydrogens. and I'm going to check and see if everything is what needs to be there. It has a carbonyl. Check. It's got 5 carbons, 1, 2, 3, 4, 5 carbons, 10 hydrogens, 3, 4, 5, 6, 7, 8, 9, 10, 2 oxygens, and it has 0 hydrogen bond donors. There's no hydrogens on F, O, N, or S. And in this case, it's only got oxygen of those 4, so there's no hydrogen directly bonded to oxygen. Ladies and gentlemen, I like it. I'll take it. Now, there's probably other ways to do this. We don't want to spend all our time doing possible ones of these, but let me throw this at you. By the way, before I leave this is an ester. R, C double bond O, O, R. That's an ester. Let's try this again. Same problem. There's our landmark carbonyl. I'm going to draw that, and I'm going to put a hydrogen on this side, and then this is an aldehyde, by the way. Right now I've got an aldehyde. It's a terminal fragment. This bond's a little too long. This is me just being OCD. Sorry. There we go. And now I've got to add everything else moving to the right, if you will. Okay, and so I'm going to go ahead and put a carbon and a carbon. I got to add 5 total carbons, so I've had 1 to start with carbonyl. I need to add 4 more. 1, 2. I think I'll put this oxygen somewhere in between these 4 carbons. Hey, what about that? Does this fit the rules of bonding that we have? Yes, let me go ahead and add the hydrogens. Does it fit the formula? I believe it does. 5 carbons. I see 2 oxygens. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Does it have a carbonyl? Yes, it does have a carbonyl. Does it have 0 hydrogen bond donors? That's true. There are no hydrogen bond donors in this molecule that I've just drawn because there's no hydrogen on oxygen. Ladies and gentlemen, I'll like it. I'll take it. This will work. Just for extra practice, what's the classification of this molecule that we've drawn? This right here makes it an aldehyde, and this right here makes it an ether. An aldehyde is R, C double bond O, H, and ether is an R, O, R. This concludes video number 1 on drawing organic molecules.